In this shop, I formerly had a whole wall of 3D printers, and I used them to pay the family bills. This little printer farm was actually my sole source of income for about 3 years. And I made spinning wheels. I made a lot of fiber arts tools, and that's because I happen to know that fiber arts tools are expensive. And so it was a good thing for me to try to make with the 3D printers. They're simple, old school, low tech, and ideally, I'd be able to save somebody money at the same time as making myself some. That was the idea. The product that got away from me is this one. I tried making a carding drum a couple of times. This is a tool that prepares the fiber of a sheep and gets it ready for spinning. You can technically spin without preparing fiber, but it is so much better if it's prepared. It's consistent. The hard part of spinning is maintaining a consistent thickness of your thread, and that stretching action you do when you're stretching the fiber in order to get it to the consistent diameter is way easier if the material itself is consistent. For that purpose, people have been using things like carding brushes for a really long time to get all of the fiber tangled in a consistent way so it drafts out as a single mass. And you end up with this really easy material to work with. However, the carding material itself, if you'll see, is made of these little spring steel teeth that are set into a cloth backing. The stuff is called carding cloth. And that name comes from the Latin word for a teasel, even though teasels were never used for this process. These are little staples. If you move one tooth, you'll see they are always in pairs. Unfortunately, it's specialist. It's hard to get and it's expensive. And for that reason, these things, a carding drum in general, is a wildly expensive product. So I want to show you a couple things I did wrong in designing this, a couple of ideas I had for how to get around the carding cloth problem, maybe how to 3D print it myself, and hopefully there will be something useful and enjoyable for you here. This thing is technically functional as is. This is carding cloth that I purchased from the Howard Brush Company. They fortunately still sell it, and they're a US-based manufacturer, so that's really cool. It is still very, very expensive to get a hold of this stuff. But by making the drum narrow like this, I minimized that cost, and I figured I could make a profit selling this unit. Skateboard bearings just happen to be the exact size of a 5/16 inch bolt. So I had this idea of using a 5/16 inch threaded rod to go all the way across. I needed to have the pulley drive this thing. And to do that, I have to have both the pulley and the drum grip onto the shaft. My idea for that was to use nuts. If you look really closely in there, I have a hole that is hexagon shaped, just the size of a nut. Might be easier to see it on this side, or at least it would be if it wasn't covered in fluff. But you can see it pretty well right there. There is a hexagon shaped cutout that fits perfectly on that nut. And so my idea was the nut, as it turns, will drive this thing around. But to keep the nut from sliding up and down on the threaded shaft, I have to use these lock nuts. Jam two nuts together, and then they'll hold still. And I have the same thing here, and there's, I believe, two nuts here as well, and then there's two nuts here as well. In theory, that would work fine, but in practice, things don't stay where they're supposed to be, and these nuts loosened up, and then this whole thing starts drifting to the side and then pinching against this. It's not a great design. To get around that, I've made this. This is a 3D printed piece that has space for a square-shaped M3 nut, and then that aligns with the hole right here. That allows it to pinch onto a 5/16 inch bar. There's no threading on that, and that will pinch properly and get that to bind onto the shaft, and that to bind onto the shaft, and then this thing will turn as it should. The next thing that I'm going to improve on the design is this tension mechanism. Right now there is a spring that is holding this. Ooh, there we go. Right now there is a spring that is moving this arm backward. That is putting tension onto the belt because this pulley and this thing need to turn in opposite directions. That would be super easy to do with gears, but the trouble is this distance depends on what kind of carding cloth you're using. And it's kind of nice that you can change the distance from here to here just by unscrewing this and moving it if you were using a different piece of carding cloth. And if I was using gears, then there's two problems. One is gears can potentially pinch in fiber and fingers. And the other disadvantage with gears is they have to be within a very narrow width in order for it to function. So the belt was the preferred way. This is 3D printer filament of a material called TPU, which is a polyurethane. It is a flexible, rubbery-like filament, and if you buy the 3mm length or 3mm diameter, that's what this is. And I just use a lighter to get the two ends to melt together. It's a little thinner than I'd like. I think I'll braid it in the future. But that's the general idea. We've got a ratio between here and here. That's good. This tension mechanism I don't love. Springs, turns out, are kind of expensive. And I don't love the way this is attached. I also don't like that I have to pre-drill the holes for here and here. So what I'm thinking of doing is redesigning this tension mechanism so that there will be no hole needed here, no hole needed here, and no spring needed. One of the things that fascinates me about carding cloth is that it predates the invention of mechanical spinning. It is old. Carding cloth like this with hand carders is seen in some medieval manuscripts, so it's been around for at least 500 years. And then the spinning frame, the magical invention of Mr. Richard Arkwright that started the Industrial Revolution in earnest, that was where it started, making string. That was the moment when the Industrial Revolution as we really know it, with factory labor and division and, the robber barons developing insane wealth, all that started with Richard Arkwright making string. But what did he use as the basis for that? He had a machine that could stretch fiber consistently and spin it, but to do that you have to have the fiber pre-prepared using a machine similar to this one. And to do that you have to have industrial carding cloth. And I don't know what machine he was using. I don't know if he had any role in inventing the machine that prepared the fiber. The fiber in its preparation, the way that it was used in his spinning frame, which is the machine that actually spun the thread, what went into that machine is called sliver. It is a long, thin length of prepared fiber that looks a little bit like this. And you have to have big spools of it, pre-combed and ready to go. I don't know exactly what machine he was using. I know what came after when you have, carding mills developed, but I want to learn more about what developed before that. Another thing that I'm curious about is in the very first inventions of these carding machines, they're called needle sticks. And I had an idea for how to replicate something like that. Over here, I have a box of failed prototypes for my carding efforts, which we'll open up. And I had this idea of using nails set into a 3D printed backing, like this. These are nails set in a 3D printed backing, and I had this idea of having sticks of them with screw holes that could then mount onto a shaft like this. So the way this would work in practice would be something like that, except with nails all the way around. To get the holes exactly the right size was a bit of a pain. Another idea that I had, which did not work out, was to 3D print the teeth on them out of plastic. If you 3D print in this vertical orientation and then have a separate platform along here, you can bridge the gap with 3D printer filament and make, a long, narrow bridge. And then if you cut away the second tower, you'll be left with these teeth. Unfortunately, in the act of cutting them, they end up kind of jagged. So they bound onto the fiber a little bit too much. And here I've got an example of some carding brushes that I attempted to make this way. And they kind of sort of work, but you'll see that there are some teeth missing there in the middle. Those teeth broke off because plastic is not a great material for this. Steel really would be better. I did not try with some of the better 3D printing plastics for this. I could have used PETG, and that might have improved it. This is PLA, which is known for being a little bit brittle, but it wasn't great, especially if I was going to sell it as a product that someone would use repeatedly. I didn't have confidence that I could make that work. With the needle sticks, that could work, but then the labor involved in putting all those pins in by hand and then gluing them in by hand, because they would fall out the back, was a little excessive. As of right now, I think my best bet is to just use purchased carding cloth and to improve the other details and kind of accept, a profit margin that includes that large upfront cost. Another thing that I'm curious about with the carding drum and with carding cloth has to do with the spinning jenny. If you've heard of the spinning jenny before, it's an invention that predates Richard Arkwright's water frame. It was pretty similar to this spinning wheel. This is a charka style spinning wheel with a quill on the end. And the idea with a spinning jenny is that you had a bunch of spinning quills similar to the one that fits into that insert right there. And they would all be spinning at the same time. And then you would have a sliver, again, a prepared bat of fiber, going to each one of those spindles with a clamp that could close all of them at once. So you would spin with one hand, clamp with the other, slide back like a drawer pull, and then you would adjust a lever which would make a bar fall across those spindles. Now instead of spinning the fibers, they're going to wind up. So then you wind with your right hand, move forward your hand with that drawer pull on the left, and you could spin skillfully, 6, 7, 8 strands at the same time. 6, 7, 8 times more efficient than doing just one. But again, this invention required prepared sliver. I don't know how that was being done. There is an invention that does the same thing that was done in India in the 1950s. Gandhi had this X Prize where he wanted a more mechanized way of spinning brought to the people. The reason why the Indian flag has a spinning wheel on it was because of Gandhi's obsession with spinning. He really believed that that was the way that India was going to develop independence, was by revitalizing cottage industry, taking jobs away from the factory, and by spinning their own cotton, they would reduce both the market for British exports of cotton goods, and also they would develop a spirit of independence. And so he basically thought he could break the back of the British Empire with spinning. And he was right. The trouble is, spinning by hand using a charka like that, even while it's meditative, is horribly inefficient. If you're trying to make clothes that way, it's miserable. Don't do it. Unless you like the challenge, in which case do it for the challenge. But if you don't want the challenge, it would be nice if there was some intermediate level of technology, something that would allow you to produce at scale at home. And so put out this prize and said, whoever develops this will get a cash prize if they're willing to dedicate the design to the public domain. And it was claimed in 1950s by a man named Ambernath after Gandhi's passing. And this guy developed 2 machines. One was called the Ambar Charka, which was the spinning machine that could spin 4 threads at once, just with a hand crank, very similar to Arkwright's water frame. And the other was called the Ambar Belny. And this device used a series of rollers, and here is my attempt at making one, to stretch the fiber. So you would have an initial combing that you did presumably by hand. And then you would pass that through these rollers and it would stretch it. So it would be twice as long and half as thick each time it went through the rollers. And if you did that a couple of times, then you would have your prepared slivers for the spinning machine. This is another one that I haven't quite dialed in. Similar problem with the threaded rod. With the same solution, I can probably solve both. So that's another one that didn't make it. What I'd like to do over the next week is fix this design completely and get it running. I want this thing to be effective and a little bit brain dead and good enough to be a product, to the quality that I would have put on my shop back when I ran it. My commitment to you, dear viewer, is that next week's video is going to be an update on how this revisit of the project worked, whether I got it running, and if it worked, we're going to post design files and try to get this thing up and running. Thank you so much for supporting these videos. It really means a lot to me. If you want to support us on Patreon, please check the link below, and we look forward to seeing you next time.